Hello people! Right, now if you're a true subscriber to my channel, you've seen Into the West. You've seen 8 series of Benito's explanations. You have seen the smash hit Chucklevision Series 3 song, which has been my most successful video in, well, ages. You have seen all the revision videos I've done so far this year and last year. But this is the video of all videos, folks. This is Benito's explanation of AS Maths trig equations. Oh, anyway, let's get on with it, shall we? Now, I've sort of handpicked randomly a simple random sample, everyone. That's statistics, but we're doing cool anyway. Of a trig equation, because this, well, I think is probably the hardest bit in Core 2. This and logarithms. So I haven't actually looked at this question properly before I started recording, so let's just see what happens, right? Now, I'm going to start off, I don't care what people say, I'm going to start off by drawing my sine graph and my cos graph on the book. So I've looked at the question and it's clearly going to involve a bit of knowledge about that. Now, I'm not the best drawer, but you can get the idea with that drawing. That's y equals sine x. Cos graph is very similar. So remember, that's 1, that's minus 1 here. Same goes for this one. And we might as well label it here as well. So that's 90 degrees. Actually, I've just read the question. We're working in radians. So, well, I don't really have enough time to go into explain what radians are, but you probably know if you have got this far, to be honest with you, in the course. So that there's pi over 2. 90 degrees is the same as pi over 2. 180 degrees is then must be pi, and this is 2 pi over 3, and this now is 2 pi. 2 pi equals 360 degrees. So this here is pi over 2, that's pi, that's 3 pi over 2, and here, oh my god, goodness me. Oh, what do I have for dinner? I can't remember. Anyway, that doesn't really matter. Okay, so there we go, we've got our graph here, and we're going to be using that and its symmetry in this question. Well, I presume anyway, they always are. So it says, oh my god, well, it starts off by saying, sketch the graph of y equals cos x in the interval. Well, we've done that. There you go. We just did something without even reading the question. There you go, in the interval 0 to 2 pi, state the values of the intercepts with the coordinate axis. Well, that's nice, isn't it? Okay. BI, given that sine squared theta, so let's write this down, sine squared theta equals cos theta, I'm not really taking control of this camera very well, cos theta take over 2 minus cos theta. Prove that cos theta equals a half, and this is worth 2 marks. And to be honest with you, it isn't that bad at all. This light's getting a bit weird. Now, looking at that, those brackets are praying to be expanded, let's be honest. Right, so, sine squared theta equals 2 cos theta minus cos squared theta. Right. Now, the trick is here is to get everything in either all of sine or all of cos. Because we can't deal with an equation, well, it's asking us to say what cos theta equals. So it's saying, basically, get rid of sine and write sine in terms of cos. And looking at that, it's clearly the easiest thing to do if we remember a few identities. Here's the identity we're using. Sine squared theta plus cos squared theta equals 1. Right? So, if we rearrange that to make sine squared theta the subject, we can say that sine squared theta equals 1 minus cos squared theta. So that means whenever we see sine squared theta here, we can replace it with 1 minus cos squared theta. Let's do exactly that. So we now say that 1 minus cos squared theta equals 2 cos theta minus cos squared theta. Right, and from there, it's really quite simple. we've got a minus cos squared theta and a minus cos squared theta on both sides. So if we were to add cos squared theta to both sides, then, well, they cancel each other out. So we can say that 1 equals 2 cos theta, can't we? Therefore, cos theta, if we divide both sides by 2, equals a half. Yes? So, that's 2 marks in the bag. It looks like a lot of work in there, but that's only 2 marks. Right, here's the 4 mark one. Hence, solve the equation sine squared 2x equals cos 2x, open brackets 2 minus cos x. Okay. They're trying to mess with you a little bit here. They basically replace theta with 2x. And to be honest with you, it's exactly the same thing. So, let's replace, just for convenience here, we're going to replace all the thetas in here with 2x from the beginning, because it's exactly the same, we just have to do a little step at the end to make everything make sense. Right, feel free to fast forward at this point. Right, this is going to take a bit of time. Right, speed. In this time, you can have a scroll down to see my full range of videos if you want to give them a gander. See, what a plug, eh? I did that especially. Right. There we go, we're nearly there. Right, okay. There we go. I was thinking of a joke then. I couldn't think of one. Anyway. I should do a funny maths video. So what we're saying is that cos of 2x equals a half. Now it's very important, because we are working in radians here, to have your calculator in radians, which I'm just realising that mine isn't, so I'm just going to change that in now. Okay, we're in radians. Now, cos of 2x equals a half, so first we have to shift cos, we have to inverse cos, so we can get what 2x equals. Now, shift cos of 0.5, I can tell you that equals 1.042, let's say. Now, something's got to be stressed here. You could divide by 2 now. That would be nice. That would give you one answer. Unfortunately, that's not the right answer, because the graph of y equals cos 2x isn't the same as the y equals cos x. It has been stretched scale factor of a half. So basically, if you look at this cos graph here, it's basically that, but it's been squished in. So we're not going to have a normal graph. And it says, find the solutions in the interval 0 to pi. So what I do, I'd extend the interval to sort of stretch the graph again, so we get a normal sine graph. How do we get a normal sine graph? Cos graph, I mean. Well, we're going to have to times everything by 2. So we're going to times the interval by 2. Oop. 0, 2x to 2 pi. Right, that way we've got a normal graph which we can work with, and then we can find all our results from that graph, and then to divide everything by 2 so we can get back to the graph we had to start with. Otherwise, we're missing things out. So we've got our cos graph here, we don't need the sine one at all. So we've got 1.042 here. Now, that, I don't know, let's say that's there. Right, and remember we're now doing it in the interval of 0 to 2 pi. So there's only one other answer which is going to lie in that interval, and that's somewhere up here, isn't it? If we're using the symmetry, and that's exactly what we're going to do. We're going to use the symmetry to find out what this point is here. Now, this 1.042 is 1.042 distances away from 0. That distance from 2 pi is exactly the same. So all we're going to do, 2 pi take away 1.042 to get what that is. Okay? because this distance, oh, that isn't a very good line, and this distance are exactly the same. The distance between here is 1.042, the distance between here is 1.042. So let's do now, what we're doing, 2 pi take away 1.042. Bash that in on the calculator. That equals 5.236. So we've now got 2x equals 1.042 and 5.236. Then that is when we divide by 2 to get our x value, so we get the graph which we started with. So divide that by 2. 5.236 divided by 2 equals 2.618. And 1.04 divided by 2, this probably isn't going to be very accurate now because I did round up the first time. But it's 0.521. So this is radians. So normally I see them, they put a C there. So there are your answers, folks. Can I just check that really quickly? 0.524. Well, that's rounded up, so who cares? And 2.6. Yeah, that is right. I can assure you that everything I did there was correct. So that's it. Do you want me to hold the thing up so you can sort of print screen my working or something like that? That would be modern, wouldn't it? Right. There you go. You've had your moment now. So see ya. Adios, amigos. See you soon.